Very good morning to you, student. Now let us come to the problems of solving this polynomial concurrence or fx concurrent to 0 modulo prime power using the theorem that I have just sent to you and on what are the method of solving a concurrence modulo prime power. So here, suppose here I wish to solve this concurrence x cubed plus 2x plus 2 concurrent to 0 modulo 7 squared. Prime power means 7 here is a prime number, as you know, as we all know it. So here how to solve this problem, concurrence modulo prime power. So before I solve this using that explanation on the concurrence modulo prime power, that theorem. So first let me state you this complete residue system modulo m. Though it is in unit 2, but I'll need the definition of this to solve this. Okay. So here let m be a fixed positive integer and a set of m integers, say R1, R2, R3 dash Rm, is called a complete residue system modulo m if no two of them is concurrent modulo m. If suppose you have R1, R2 dash dash Rm is a set of m positive integers, then this set is called a complete residue system modulo m if no two of them is concurrent, means R1 cannot be concurrent to R2 mod m, and they is not concurrent to R2 means no two of them is concurrent modulo m. In general, Ri is not concurrent to Rj for I different from j. So let us just see this note. Observe that if you have R1, R2 dash Rm is a complete residue system modulo m, then given any a belong to the set of integers, that a will be concurrent to exactly one of this CRS, complete residue system modulo m. Why? Because whatever a you take, it must be concurrent to exactly one of this, either to R1, R2 dash dash or to Rm. And number 2 is that if Ri here is concurrent to Rj mod m, it implies that I will be equal to j, because according to definition, if R1, R2 is Rm is a complete residue system modulo m, then no two of them will be concurrent to each other, means Ri is not concurrent to Rj mod m for I different from j. So suppose they are concurrent, it means that two of them they are concurrent to each other, that is Ri is concurrent to Rj mod m, implies that I here will be equal to j. For example, you take m here is a fixed positive integer, that is 3. Then the set of 3 integers 0, 1, 2 is a complete residue system modulo 3, since given any a belong to set, a will be concurrent to exactly one of this, either 0, 1 or 2 modulo 3. For example, you can take a is equal to 4, which is an integer, then 4 will be concurrent to 1, because 4 minus 1 is equal to 3, which is divisible by 3, so it is concurrent to exactly one of this. And if you take a is equal to 5, then 5 is concurrent to 2. It cannot concurrent to any two of this. It will concurrent to exactly one of this set of CRS modulo 3. And so on. If you take x is equal to a is equal to 6, then 6 will be concurrent to exactly one of this, that is 0 modulo 3, because 6 minus 0, when you divide it by 3, it is equal to 2. So with the help of this definition, I am going to solve the problems on the solution of concurrence modulo prime power. For example, this one, x cubed plus 2x plus 2 concurrence modulo 7 square. So based on yesterday's theorem, what does the theorem states? It states like this: let fx be a polynomial over the set of integers and of degree r greater than equal to 1, and let p be a prime n greater than equal to 1, and let y be any solution of this fx concurrent to 0 modulo p to power n. Fx here you compare it with this x square plus 2x plus 2. P here you replace it by 7, and n plus 1 here you replace it by 2. Then y is equal to xi plus t into pi, where xi is greater than equal to 0 but less than equal to p to power n, and xi is a solution of concurrence modulo p to the power n. So in this case, first we have to find the solution of concurrence modulo 7 in order to find the solution of concurrence modulo 7 square. And t satisfy this one. This is an important formula. to find whether the solution of this fx concurrence modulo prime power exists or not. Okay, so based on this, I'm going to prove this problem, that is this one, x square plus 2x plus 2 concurrent to 0 mod 7 square. So to solve this, the complete, first let us write down according to the theorem. We have to find the solution of x square plus 2x plus 2 concurrent to 0 mod 7. In order to find the solution of this mod 7 square, first of all we have to find the solution of concurrence modulo 7. Name this as equation 1 and this as equation 2. So here the CRS modulo 7 based on this definition are 0, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. These are the set of complete residue system modulo 7. Now we see that from among this CRS modulo 7, 2 and 3 satisfy the concurrence, this one concurrence 2, that is you replace this is 2 cubed. Okay, this is x cubed, not 2 cubed. Satisfy this one, 2 cubed plus 2 into 2 plus 2, this will be equal to 14, and 14 is divisible by 7 mod 7 is concurrent to 0 mod 7, and if you replace x by 3, then 3 cubed plus 2 into 3 plus 2 will give you 35. Again, this is divisible by 7, so it is concurrent to 0 mod 7. The rest, if you replace by 0, 1, 4, 5, 6, they are not concurrent to 0, or we can say that it is not divisible by 7. So now from among this we see that x1 is equal to 2 and x2 is equal to 3, or we can say that let x1 concurrent to 2 mod 7 and x2 is concurrent to 3 mod 7, because these two satisfy the concurrence modulo 7. Next step here we have, in this problem we have f of x is equal to x cubed plus 2x plus 2. So you differentiate this with respect to x, what you get is 3x square plus 2. And what is p? P you compare with the theorem, it is 7, and n here is equal to 1. So if you let I is equal to 1, then the concurrence, according to the main theorem, then the concurrence t into f prime of xi will be concurrent to minus f of xi divided by p to the power n mod p. Then this concurrence becomes t into f prime. By letting I is equal to 1, it means that you take x1 equal to 2. So we have f prime of 2 will be concurrent to minus f of 2 divided by 7 because n is equal to 1, so 7 to the power 1 mod 7. This is equation 3. So from here, what is f prime of 2? If you replace x by 2, you will get 14. So you get 14t is concurrent to minus, what is f of 2? F of 2 here is again 14 minus 14 divided by 7 mod 7, or you can write here 14t is concurrent to minus 2 mod 7, and you can see that from the left hand side 14 is still divisible by 7. So when you means 14 is concurrent, 14 is concurrent to 0 mod 7. So this implies that instead of 14 2, I'll write it as 14 is concurrent t here 0 into t, because 14 is concurrent to 0, so in place of 14 I'll write it as 0 into 2 is concurrent to minus 2 mod 7, and name this as equation 4. But this is not possible because here it is okay, minus 2, you can write it is concurrent to 5 mod 7. Whatever t you take, you multiply with 0 becomes 0. So 0 minus 5 is not divisible by 7. So from here, therefore, the solution x1 equal to 2 is ruled out. So if we let I now equal to 2, then the concurrence, again this concurrent tree, this one becomes tf prime of 3 is concurrent to minus f of 3 divided by 7 mod 7. And from here, the f prime of 3, it becomes 29t. You replace x here, you replace x by 3, so this will become 29t concurrent to f of 3 here will become minus 5. When you divide it by 7, that is 35. So here you have mod 7. So this is mod 7, or now 29. 29 when you divide it by 7, 7 4 is 28, so remainder is 1. So means that 29 here is concurrent to 1 mod 7. Is concurrent to 1 mod 7. So instead of 29, you write as 1 into t is concurrent to minus 5 mod 7. And we know that minus 5 is concurrent to 2 mod 7, because when you bring this 2 to this, it will become minus 5 minus 2, that is minus 7 divisible by 7. So instead of writing minus 5, I'll write it as 2 mod 7, or you can write t here is concurrent to 2 mod 7. Now this is equation, because here this is 5 and this is 6. Then we obtain, so here this is possible, so thus we obtain a corresponding solution of the concurrence. What is that concurrence 1? Concurrence 1. And the solution of concurrent ones, solution of that equation 1 will be in the form y is equal to xi plus t into p to the power n. But n here is equal to 1, and xi here will satisfy this concurrence here. This equation concurrence 2 here, it is by taking x equal to 3 plus, and what is t? The possible values of t here is greater, as you can see from here, t is concurrent to 2 mod 7, t is concurrent, so here you replace t by 2 and p by 7, because n here is equal to 1, 2 into 7 mod 7. And okay, what is this? 3 plus 2 into 7, that is 17. So this implies that y here is concurrent to 17 mod 7 square. Will be the solution of this concurrence x cubed plus 2x plus 2 concurrent to 0 mod 7 square. And if you want to verify it also, verify in the equation 1. What is equation 1 here? This is equation 1. By taking y is equal to 17, so 17 cubed plus 2 into 17 plus 2 will be equal to 4949, and this is can be written as 49 into 101, which is concurrent to 0 mod 7 square, because 49 is divisible by 7 square. So that's all.